All right. Hello, everyone. Today I am streaming to show Langfuse and how I integrated Langfuse into an Azure AI sample. So Langfuse is an open source LLM engineering platform, which is how they call it. I think of it as observability, LLM observability, because that's the term that people like to use these days. Basically being able to see our traces. It does do a lot more than traces. It also, as you say, does evals and prompt management. But I'm primarily interested in the traces and the metrics so that I have a very easy way of seeing everything coming into the app and seeing things like the latency and the number of tokens and stuff like that. So that's all I've used it for so far. But do keep in mind that they have other stuff as well. Now, I'm not affiliated with Langfuse at all. I heard about it from a customer that's using it for observability for our Azure AI, deployments. And so I thought I'd check it out, and it's pretty cool. It is an open source. It's open source, SDK and product, but they've got their own platform that you can deploy on, and presumably that's how they're going to make money. But it's always lovely when something is open source, so we can actually look at the code and see how it works. So let's get into it. So if we take a look at the docs, you can see how to integrate Langfuse. You can integrate using their actual SDK, or what I am doing is integrating using this OpenAI SDK, basically monkey patching. So what you can see is that if you're already importing the OpenAI SDK, instead of importing OpenAI, you import from langfuse.openai, and then you get everything that way. So they basically wrapped on top of stuff so that they can intercept the calls that you make through the OpenAI SDK. So that's the way I've done it. You can see lots of other things that they integrate with. They've got like monkey patches on top of all these. So LangChain, Llama Index, Light LLM, LangFlow, FlowWise. I haven't even used all these ones here. There's so many things. We also, of course, need to install Langfuse in our environment. And we already have the OpenAI SDK. And then we need to set some variables so that it knows where to find the Langfuse server so it can send all the traces to it. There's also this optional auth check. I haven't tried that out, but that's to make sure that everything's set up correctly. All right, so I've done that in my repo, and as usual, I am testing this out with Azure Search OpenAI demo. This is like our RAG starter app repo, where we learned a lot about how to make a great RAG app, and which lots of developers use this as their starting point for their RAG applications. And if you don't know about RAG, it means being able to get an LLM to answer based off of retrieved data sources. So I've got that locally. And I've made the changes so we can see in app.py for my imports. I've got, let's just search for Langfuse. Okay, so I'm actually importing from langfuse.openai. I'm importing the clients that we're using. So I did that because this is how we use the SDK, is via these two clients. And that's the only import I had to change. We do have imports from OpenAI in lots of other files, but those are usually just to refer to types. This is the only place where we actually initialize those clients. And just doing the import here was enough to be able to hook into Langfuse. So yeah, so that's it. We've got that import there. I've also set the environment variables. I'm not going to show you those because they're secret, but I have also set the environment variables. And now I've got the app running locally here, so we can check it out locally. So here it is. And it's just, this is a RAG app, where I can ask questions about my own blog. So here you can see, okay, I'll reload. I think I just added some example questions here. So we'll watch as it sends out a request. All right, and it's streaming in the response here, and these are sleep strategies based off of a blog post I wrote. And we can see the thought process in our app UI and also the supporting content for this answer. Now, since I've tied into Langfuse, I should be able to see this show up in Langfuse as well. So Langfuse is, it's an SDK, and then it's also a UI on top of that SDK, and you can host it really easily yourself. So you can use the Langfuse platform, but you can also host this whole app very easily yourself. And the docs for that are here. Is self-host. There's the local option, and this is just for your experimentation. Obviously, you shouldn't be using this for production. But this, there you git clone and Docker compose up. And this was super easy to do. You can see that's what I did. I git cloned and then I Docker composed up, and it starts up a Postgres database where they're using Prisma to communicate with that. And then it starts up the server, which I think is a JavaScript server. So that is running there. So we can check that out. So here is the locally running server. And you can see these traces are from February 27th. So I was running this a few days ago to test it out. Let me click on these ones. These ones should have, oh, those ones are all null. Okay, well, we'll see it actually show up in the one I'm actually running in production. So that was the local one. So I wanted to show you that, yeah, you can get started really easily with Docker Compose Up just to check it out. Now, I wanted to make it super easy to host it on Azure. And they have all these instructions here about how to host it because they have the container image. So you should just be able to, anywhere that supports, a Docker container image should be able to run Langfuse. So you need a Postgres database, and you need the ability to host this container app. And then you need the secrets and the environment variables to connect them together. So you can see here, they, have this simple example, and then they have this list of the environment variables. So I like it to be really, really simple to deploy stuff to Azure, being able to do it in like a couple commands. So I've made Langfuse on Azure is a repo which has it all set up for deployment to Azure. Here I'm using Azure Container Apps, which is a great way to deploy images. And it's like a wrapper of Kubernetes. So it does all the Kubernetes hard stuff for us. So it's got auto scaling, scaling to zero, consumption-based pricing, all that good stuff. So this repo, you should be able to deploy using AZD. And it's got all this infrastructure as code that describes how to deploy it. So you see, we make a key vault for storing some secrets. We make the Postgres server. We make the container app environment. We make the container app. We point it at Langfuse here. So this is the official Langfuse image. And then we set up some environment variables. So we've got the connection to database hosts. The next auth URL, this is how it does authentication. And these are these optional things for setting up Azure AD authentication. I'm debating if it even should be optional, because if you're deploying to Azure, you probably most of the time want to use Azure AD. I suppose it should be optional though. And then we store the key vault secrets. So that's all in the bicep. Now we also have the parameters that passes in. Okay, so we have this bicep that sets everything up. And these are commands. So this is what I used in order to deploy it. So now I've got it running. You can see this is on the container apps URL here. And here is, an example of generations from the app. So these are really recent. These are from today. So I'll click on one of these. And this is one thing that confuses me, is that sometimes I see null for things. Okay, so this one's not null. So here you can see an example where it's, it's showing, lots of things about it. It shows the latency, the temperature, the model used, how many tokens were in the prompt, how many were in the response. These are all parameters we passed in. So it shows us all that information. And then it shows the system prompt, the user prompt, and then the response. And if it's interesting, you look at our traces. I never actually know whether to use generations or traces. So I'm still learning to use this. I think I like generations better. So if you look at the generations, it's pretty interesting because you can see there's a mix of kind of token sizes, you'll see that there's some where it has a very short, like 260, and then the response is 18. 373, the response is 6. And then we have ones where like the input is around 1,000, and then the response is something larger. And that's because we actually use a call to chat completion twice during this thought process here, right? So first, we convert the user query into a good keyword search query using a chat completion call, and also using function calling. So that's why we saw the function calling there. And then we get the search results, and then we do our final chat completion call to actually answer that question. So in our generations, we really see a mix of these calls. All right, so let's actually do one and see show up. Or actually, I was just even going to run a load test, right? Because if you're using observability framework, like it's probably because you're trying to observe things, at a higher level because you've got lots of usage, right? So what I can do is go here and run Locust, which is a way of running load tests, and that's what I like to use. There's also Azure load testing. I'm just not familiar with it yet, but I'm going to learn. So then we have to enter in the URL, and we're just going to do it locally right now. And we'll just do a small number of users, is like 5, just to get some data. And that sounds good. So it will start sending requests, and we can see what the requests are that it's going to send in the Locust file. Right, so it's going to send requests to first get the home page. So those be, load requests that don't log anything with Langfuse. But then it's going to send a request to the chat endpoint, and that should log 2 calls each with Langfuse. So let's see here. We're ramping up the number of users. The users are probably starting to actually ask some questions. So we can go back here. Oh, and I can actually see it. It looks like it's actually updating in real time. I guess, that's the advantage of using JavaScript, right? We can update real time. So you can see this one happened at 3:12. So we can take a look at that trace. Let me see. Oh, I think I have to click on this ID. Yeah, in order to see the responses here. So here we can see this is the actual chat completion call that answers the question, right? So it says, so this one's interesting. This one's actually where I'm testing a whole conversation, like a multi-turn conversation. So we have system, user, assistant, user, assistant. So just testing a little more load with this one. So we got 993 in the prompt, 36 in the completion. So this is really cool. So I like this page the most. You can do lots of filters. So if I was trying to find just ones, from today, I could, do that filter here. We can change what columns, right? So for some reason, we don't have time to first token yet. I asked the team about that to see why that doesn't show up yet, maybe due to something with our OpenAI configuration. We've got time per output token. Now, this one's really, really interesting because what I realized was looking at the time that things took, like looking at the latency column here, there's a big range, especially when you're using GPT-4. So we can try switching this one over to GPT-4 and seeing the results. But there's a big range in the latency, and a lot of times that range has to do with just how many tokens are involved. So it's really helpful that it does have this time per output column here. Now, there's also a dashboard. So in this dashboard, we can see, like here, we probably want to filter. Let's just do the last 30 minutes. And we can see our token cost. And if we have multiple models, it'll show us per model. So we can try switching over to GPT-4. We can see the latencies. So this is also really interesting when if you've got multiple models involved, and so you can get different percentiles. And there's other things as well that I'm just not using yet, like scores. Okay, so now let's try switching it over to GPT-4. So I do have a GPT-4 I can use in this environment. So I just need to change this to Chat4 and GPT-4. That should do it. And let me stop running the load test for now. And then I'll just restart the app so that it picks up the new environments. We're doing GPT-4 and the chat 4. Okay. Okay. So let's give that a go. All right. Do we have any questions in the chat? Hello, John. John, oh, I should, John. So John recently submitted the HTML parser to this repo. So you can see that here, local HTML parser. And I did actually use that. So I am currently using that in this one I'm showing. I redid my whole index using the local parser so that I can have more control over the HTML that came out. And it's working really well. So I do recommend the local HTML parser. Like if you're doing what I did and making a rag on your blog, it works great. You can modify it really easily. Like I can show you the modifications that I made for mine, right? So with mine, I wanted to only get what was inside the blog post class because I didn't want all this junk that was around it. So that was it. I just made that one modification and I got much better chunks out of that because I'm not getting all the cruft that was around the blog post. All right, John has a question. Okay, how did I connect between the container app Langfuse and the local app? Yeah, so I connected it using environment variables. So what will happen is that if you go, I'd figure out how to, let me try and do this without showing you, keys. But, what you see here, this is on my local one. So you'll see API keys, public key, secret key, right? So these ones need to be environment variables. Let's see if I can get the pop-up again, because the first time you do it, great. So when you create new keys, once again, keep in mind, these are my local keys, so nothing untoward happening here. But then what you do, click on this, and it's really nice. It gives you exactly what to do, right? So you make sure you have got Langfuse installed in your environment. And then you set these in your environment file, presuming that's what you're using. So I sent them in my .azure.env. So, those of you who know AZD, we've got these .env files. So mine are actually set in this file at the very bottom. Another nice thing to do would be to store these in a key vault, since these are keys and I get the heebie-jeebies even having them in .env files, right? The ideal is to stick them in a key vault so you can't accidentally reveal them. That's always the goal. So it'd be very nice to actually put these in a key vault and retrieve them there. But the basic point is that these 3 environment variables do need to be set in your environment so that it knows where to connect to. So this is when you're local. When you're, in your production one, it'll give you the host of the production one. And then you need to change your OpenAI import. So these are the 3 steps. And yeah, they work pretty smoothly. So well done to the Langfuse team for that. I haven't tried it with any of the other ones, but they're trying to integrate with lots of things. So Python, JavaScript, OpenAI, LangChain, JavaScript LangChain, lots of options there. Nice question. All right, so let's see what we got going here. All right, so now we should be running on GPT-4. So how do we test if we're GPT-4? Let's see, does GPT-4 know if I have a baby? That was one that GPT-3.5 struggled with. I don't know how GPT-4 is going to do with it. I haven't tested this particular question. And of course, this being GPT-4, it is going to be slower. Oh my gosh, there we go. This was the question we were having such a hard time getting a good answer to. This is exactly the response that I want. Okay, so GPT-4 just really is much. I mean, we all know GPT-4 is better, but I wish it was faster. So yeah, Pamela has a baby. Closely when their baby was now 18 months old. Well, all right, the math on that is a little rough. I've got 2. One's 5 and one, or ish. Anyway, it got much better answer there. So go GPT-4. All right, so now we can go ahead and now I'm curious what other ones it'll do better. Like what college did Pamela attend? Because this was one that failed, and I think this is even going to fail on GPT-4. We'll see, because I think I did test this on GPT-4. It's always really interesting to me to see what it does well at. Okay, so it's really interesting. It doesn't know what college I attended, but then if I say, did Pamela graduate from USC? Maybe because it doesn't know necessarily that USC is a college, like, or yeah, I don't know exactly what's going on in its head because it knows exactly this, but yet is uncomfortable with saying which one I attended. I don't know. Anyway, let's run a load test. Let's see. All right, we still got Locust running there. So we'll just do a new test. Same thing. Start the swarm. And what we can do is open up our Langfuse. Let's go to generations. And we can start to see these. We should start to see these come in here. So we see GPT-4, 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 and you can see how the latency is going way, way up, right? So we're seeing latencies around 1 second for the short queries, and then 3 to 5 seconds for those longer queries. And I actually don't even think the load test has kicked in yet. So those were actually for the ones that we were sending there. Okay, now when we're doing the load test, we're going to see even bigger variation. So I see a 13-second here. And if we look at time per output token, we see 0.37 seconds. So that's a really high time per output token. And I should point out that I am using what's not called a pay-as-you-go subscription on Azure. So when you use pay-as-you-go, you don't have any guarantees of latency. If you know that you're going to be doing, this huge thing that's going to be using a bunch of GPT-4, GPT-3.5 calls, then what you can do is get something called provisioned throughput units, PTU. And there you're basically pre-reserving capacity. And then, when Azure does that for you, you're able to can have a max latency constraint. So that's really nice. I do not have access to the PTU for my sample, but that's what is usually recommended if you do want a lot of control over your latency and just better latency from GPT-4. All right, let's see. So we should see a lot more from here. Okay, so now let's go back to that dashboard and see. Let's filter once again to 30 minutes. And you can see also the GPT-4 is more expensive because we're seeing, model cost. So for a smaller number of tokens, GPT-4, costing more. We can see here the model latencies. Now when it compares, it's got multiple here. So GPT-3.5 to GPT-4. And I think it's getting confused between the deployment and the model ID. I'll have to look into that, whether that was my mistake or not. But, because on Azure, we have deployment IDs that are different from models. And that's not the case with just OpenAI.com. And, sometimes that can confuse frameworks. But generally, GPT-4, as you can see, is much slower. So yeah, so there you go. That's really all I've used of Langfuse so far, but so far I like it. I think it's like just a really nice way of seeing the stuff that I care about the most. It's just getting a feel for how long are things taking, what kind of tokens am I using, that's that sort of thing. They do have lots of other things here too as well that I haven't explored. So if you're interested, do check them out. If you do want to try hosting them on Azure, check out this repo. This is a very new repo. It came into existence a few hours ago. I've been working on it in my own account for a week or so, but it's very new, and I would love some bugs filed on it because I'm sure that I haven't clarified everything in the docs and that I need to improve some things about it. I need to add a dev container, that sort of thing. So yeah, but do try it out if you are interested in deploying Langfuse on Azure, and let me know what you think of it. And also, if there's other observability platforms that you're using, I'd be interested to know. We also, of course, have integration in Azure Monitor, and we've just recently tried out LLMetry, which is something that can hook into any OpenTelemetry, browser. So I'm also going to play around with that and probably do a video showing how to use OpenTelemetry as well. All right, so now we go into unstructured questions time. So we have a lot of issues on Azure Search OpenAI demo. We do. That's because I feel bad for closing people's issues. I probably should. We also have the stale bot here. It's I have a hard time like reasoning about what should be, what should be closed, because a lot of these things are not necessarily bugs in our code, but they're things that are just difficult about setting up an environment, right? Like it's hard to get Python to work consistently across Windows and Mac. It's like hard to get your Azure permissions correct. And to me, that somewhat is an issue because one, other people might run into that as well because environment setup is hard. And two, there might be something we can do in the documentation to make it easier. That's part of why I'm just, I often leave things open that I probably could be closing because quite a few things are just environment setup issues. So yeah, John suggests enable discussions. That's also what Zed suggested. And I love discussions. My one issue with discussions is that if you're searching issues, right? Like a classic one is the CFFI error that people get, right? You search issues. If these were only discussions, then we'd see like zero, we'd see like zero, and you'd have to go over to discussions. You'd have to know to go over to discussions. So what I want is for GitHub to say like, hey, there are, 5 things matching this query in discussions. Do you want to go over discussions? But it doesn't do that right now, as far as I know. That's my main, reason why I haven't enabled discussions on this yet, because we're worried about forking between the issues and the discussions and making it harder for people to find answers, right? Like the nice thing about having issues, just one issues, is that everything is just in one place. You only do one search. Now, I believe you can actually search up here. I don't know how many people do that though. And then you also end up getting code. So I think that's a confusing experience. So what I really want, GitHub, any GitHub engineer listening, technically Microsoft like owns GitHub. I should have like a better in for this, but what I really want is if I do a search here and there are 0 results, I wanted to say, hey, you should check discussions. There's something matching there. That would be amazing. But yeah, maybe we should just, enable discussion. So I can chat with the other maintainers. And you do have the ability to, convert issues, discussions, and vice versa. My concern is just somebody who comes here and who searches, and if they see no results, so let's do something that gets no results, right? If they see no results, then they'll just think, oh, okay, there's no answer here, even if there might be an answer in discussions. And I have this experience a lot because a lot of times I search GitHub repos for something I'm experiencing. And these days I have to first search issues and then remember, oh, there's a discussions tab in this repo. And then I have to go search discussions. So that's my concern, is that it could lead to a lot more developers thinking that, oh, there isn't any solution to the particular error that they're having and not being able to find it. That's my take. I don't know if I'm right, but that's my concern with enabling discussions. We could lower the barrier, because I'm fine with people at like starting discussion like things in the issue tracker, because I think also there's a fine line between issues and discussions. So I'm okay with people doing that, but it does make it a lot harder to sort through things and figure out what's an actual bug. So yeah, I mean, I can tell you things that are definite issues is that if I'm assigned to it. So there's a bunch of stuff here. So you're welcome to just ask me if I'm actually have any time to do any of these. Like this one, I assigned it to myself. I haven't worked on it. This one I started, but then there was some weird UI stuff that I was having. So that's definitely an indication if something's assigned. And yeah, other than that, yeah, I agree. It's not obvious which things are issues. The other thing that's an issue is if you go and look at pull requests, we haven't merged a lot of these pull requests, and that's because a lot of these are legitimately useful things. So like upload file from browser, I'm actually hoping to work on that so that we can have upload part of the app. And check blog hash. This is one that we do want, and the developer hasn't updated the PR. So so we need to update the PR because assuming that they've moved on to something else. So another option is to go through PRs, try them out, modernize them, but we might have plans for them. So probably the best thing is to ask us, and maybe we should enable discussions. Yeah, if you reply on issues, I do actually see all the replies that come in. And so if you say, hey, is this a good thing to work on? Then I will totally see that and reply. So I do try to go through and respond to things. Yeah, that's a great approach. All right. Cool. Okay, so that's all I want to share today. Well, for anyone who's still watching, I am also working on this. The thing I actually was doing today was a whole new set of tools and frame metrics in the AI RagChat evaluator repo for evaluating whether your bot is correctly admitting when it doesn't know, right? So for things that are off source that it shouldn't know, even if it's like public information, now I have a bunch of tools for evaluating that. So if you're interested in evaluation, check that out. I'll probably merge that shortly after this stream. But the TLDR is that I ran the evaluation. GPT 3.5 is not that good at saying that it doesn't know, and GPT-4 is very, very good at it. So another win for GPT-4 today. All right, that's it for today. Bye.